Hi everyone, my name is Martin Teschl. I'm Director for Business Development and Licensing at the Center for Technology Licensing here at Cornell on the Ithaca campus. Thanks for sharing your lunch hour with us today. I would like to welcome you to Lab to Impact, an engaging and learning engagement and learning program designed for Cornell innovators, founders, and beyond. Lab to Impact is a comprehensive webinar series offering an integrated approach intended to touch on the full journey of technology commercialization, from innovative ideas in the lab to impactful applications in the real world. The program is structured into four main modules: intellectual property, commercialization and venture insights, healthcare, and social sciences, providing participants with practical tools and insights to navigate the complexities of turning research into market-ready solutions. Today's panel, titled Lab to Impact, the Path to Commercializing Semiconductor Technology, brings together experts from industry and academia to explore the critical pathway from semiconductor innovation to commercial success. We're fortunate today to welcome a great group of panelists from the Cornell community who will share their insights and respective experiences in scaling semiconductor technologies. To kick off the discussion, I'll begin by inviting each of the panelists to introduce themselves and share a little bit about their background and expertise, maybe about 2 minutes each. Thanks again for joining us, and let's get started. Maybe Alyssa, if you could ask you for a quick introduction.
I'm Alyssa Apsel. I wear a couple of different hats here. So I'm a professor in the electrical and computer engineering department. I work on integrated circuits. I am also the department head, director of ECE. And so I have some experience working with other faculty members on commercializing technology and looking at the direction that goes in, and some knowledge of what programs exist. And I'm also a co-founder of a startup company called EchoICs with a couple of my former students.
Bob?
Good morning, everyone. I am Bob Scharf, the director of the Praxis Center for Venture Development, which is in Duffield Hall, right above CNF. The Praxis Center is a multidisciplinary startup center, beginning with typically PhDs and postdocs, and working our way all the way through the process to the pre-seed and seed round funding. And we offer hosting and lab facilities for early stage startups in physical sciences. My own background was I spent 40 years in the electronics industry, mostly in photonics, including an IPO in 2000 of a startup that I founded. And another startup that I founded was in the private military space, and I sold that startup in 2014, and that's when I ended up here at Cornell.
Great, thank you. And last but not least, Bruce, please.
Hi, my name is Bruce Fishbein. I did my undergrad at Cornell and then a PhD at Stanford, and then I worked for 30 plus years in the semiconductor industry at big, established players like Intel and AMD, and also a bunch of startups. Since I left industry, I've been advising student-led startups, mostly at Cornell and mostly through Praxis. They're all in the semiconductor area, and I've also had some angel investments that I've done. So I've seen things from investment side as well, and also through some of my contacts in Stanford and Silicon Valley.
Great, thank you very much. I should also mention before we get started, so the audience members are certainly encouraged to ask questions. If you could please use the chat function for that. We will try to see if we can work them in to the conversation as we go along, and otherwise, if we have time left at the end, we might go back to look at those questions as well. So let's get started. So maybe what I would like to ask first is, assuming many of the people in the audience are researchers themselves likely interested in semiconductor topics themselves, maybe also thinking about how they might turn their science into a business. What kind of piece of advice would the panelists give them where to start and how to think about it? If they're still in the lab, thinking hard about science. Maybe let's start with Bruce.
Well, the main thing I would say is, compared to when I was in school, the resources available to members of university communities, especially places like Cornell, big research institutions, is just amazing. I mean, I think it really sets the US apart from other companies. The amount of support, whether it's some incubator like Praxis, whether it's the Office of Technology Licensing, whether it's just members of the community who can provide advice and introductions to people in the industry. So my main piece of advice is, don't go it alone. Take advantage of those resources because, they are, first of all, just incredibly deep and helpful. And they also are a competitive difference versus, anybody you might be competing against, especially internationally.
Yeah. Bob, Alyssa, add anything?
I mean, I guess the one thing I would say, just from the perspective of an academic, there is a change of perspective required in order to commercialize your technology. That the main thing that academics are interested in is, the importance of your science. That is not what investors are interested in. The main thing that investors are interested in, or even not investors, even just buyers or anyone that you're going to work with in order to commercialize your technology. The main thing they're interested in is what is your product and what is the market for your product. And so those are like the two main focuses. There are a lot of resources, as Bruce has mentioned, at Cornell, but also in the country in general, that help you primarily figure this out, because this is really kind of a gap. And we spoke earlier about I-Corp and some of these programs, and these are tremendous programs that really help you understand what the market space is for your technology, if there is one, so that you can make that determination before you spend a lot of time and effort trying to develop a company.
Yeah,
give a shout out for the I-Core to reinforce that. That curriculum was originally developed by Professor Blank at Stanford, and it's since proliferated very widely. So the NSF sponsors I-Core, and a lot of universities and other entities follow a similar curriculum. So you have a lot of options if you want to follow that process. And the essence of it is to make and test hypotheses through interviews of key stakeholders. And there's just nothing like it in terms of, going through, say, market reports or something like that. There's no substitute for talking to people. And it's just a really, really valuable exercise. So I would encourage anybody who's thinking of a startup to put that into your plan of doing I-Core.
So I want to confirm everything Bruce and Alyssa said before, and just add, and it's important to think about getting started even while you might be a student or might still be a postdoc. You don't have to wait until you're off the Cornell payroll to begin doing all the planning and putting things in place. And there's plenty of expertise around, as Bruce and Professor Apsel mentioned. And so don't keep your plans too secret, because in many cases there are people with vast expertise who are excited to help you and guide you and provide their own expertise in supporting you, including in the Center for Technology Licensing and in Korea and other parts of the university as well.
Yeah, that's certainly that. I would add when you say don't worry too much about secrecy, right? I mean, this is what our office deals with all the time. Some researchers might be too loose on this and share things too soon before they have even talked to us or even thought about IP protection. Some might be too conservative and never want to share anything, right? So that's certainly also something that I think our our office can provide some guidance, and in particular when it comes to tech startups, semiconductor startups, you want to make sure you have thought about IP, and don't wait until you're ready to publish, right? That's really, I think, the message I would send from that perspective as well. Is there anything, any piece of advice maybe in terms of also, I mean, there's such a variety of research happening on a campus like Cornell's in semiconductor related, whether it's hardware or software or EDA tools and things of that nature. I mean, is it are, where are the hot topics right now, I guess, from your perspective, maybe?
Well, certainly we've seen a huge expansion in interest in things associated with artificial intelligence and machine learning and neural networking. Despite what you read in the paper, there are still many opportunities to provide new innovative approaches in these areas. So I see all kinds of great opportunities. That doesn't count out the many, opportunities in just new materials and new circuit platforms and new functions and new sensors. We have 6 semiconductor startups in Praxis, and no way do they ever compete with each other. They're all doing completely different things and finding great market opportunities. So I wouldn't think that there really are any restrictions now on finding opportunities. It's more what particular problem are you solving and how do we scale that into a commercial business?
Bruce, Alyssa, any thoughts on?
Yeah, I mean, I think AI is definitely, I'll agree with Bob there. Everything is in the context of AI. I feel like sometimes people don't know what they're talking about when they say AI. They just know that it's a important phrase.
Yeah.
But there are a lot of things that can be couched in the application space of AI. So that doesn't necessarily mean that the technology that you're developing and has to be a computing processor for AI. It can be something that just exists in the context of edge computing, exists in the context of data centers. These are where big investments are happening right now, is in terms of like the data centers, in terms of the application technologies for AI, but it doesn't necessarily mean that everything has to be just an AI engine directly.
Mm-hmm. Yeah, and maybe related to this, we certainly see this in our office a lot and across different technology domains and industry domains, and we always ask ourselves that question when we learn about new technologies and inventions. Would this be something that we could license tomorrow or to an established company versus not, in which case, what's the path to commercialization? Usually that means we need to figure out how to start a company, right? And who will do that? I think there are certainly areas of discovery where probably the licensing option might be more available than it always has to be a startup. I don't know if you have some thoughts, obviously, from the client companies that you have, Bob. I think they're all in the hardware space, right? Actually developing new chips and new materials, platforms.
Well, one of the startups in Praxis, Giga, their primary revenue model is actually licensing technology to large companies, and they've been very successful writing, multi-million-dollar development contracts with Google and other large companies. So it isn't absolutely a requirement that you go all the way to a product manufacturing operation, and they've been quite successful and they're growing quite rapidly in that space. But it does mean, though, that they have to get their idea to the point where they can demonstrate functionality and validation. of that product. And so they spent 4 years in the Praxis Center and worked extensively in CNF and with outside foundries, and we were helping them at every step of the way.
Maybe let's switch towards how to get the company off the ground, if that's what you want to do, right? I mean, certainly, Bruce mentioned, I mean, make sure use all the resources. I-Core, in particular for semiconductor companies, I think makes a lot of sense, right? You do need to figure out, talking to customers, potential partners. That's where that's really of increased importance. How do you find these people, and who do you connect with, right? Is it I know I've talked with a number of teams where they usually have access to scientists and engineers in large companies, but it's not always clear whether the message they're getting from those people can then be translated into a business proposition. I don't know if you have any thoughts on this.
I could comment on that. So first of all, I'll say part of the I-Core curriculum is to document a network of, who are the decision makers at potential customers. And it's not just customers. I mean, you might be in a field that requires, say, regulation. Let's say it's a defense related thing, and there might be some, government requirements or something that are really important in your product plan. So customers primarily, but other key stakeholders. So part of I-Core is to document not just who's on the org chart, but who's actually making the decisions that would influence your company, like who's making the buy decisions. And beyond I-Core, you can develop that on your own, but it's clearly, critical to do that. And there's no substitute for networking. I mean, it's not just going to drop out of the sky, and you have to use all available ways. So you can use the Cornell community network. I've seen with the companies I've advising that conferences and trade shows are really, really valuable to kind of meet people in person and establish a connection. And then, like I said at the beginning, through just sort of this kind of interview and chain of, you finish each interview with each person you talk to by saying, who else can I talk to? And then you gradually kind of a picture emerges out of all that of who the key stakeholders are and who you really need to be interacting with.
Yeah, Alyssa, I think your company has gone through this exercise maybe multiple times, and certainly it never ends either, right?
Yeah. And I think, Bruce I think it can't be overstated, honestly. He's dead on that the personal connection, that the one-on-one actually talking to people, not just relying on emails or hypotheses that you're developing from reading things online, is absolutely critical. And it's critical. It's difficult to do, especially if you're an engineer who doesn't necessarily thrive on being extroverted and talking to people. So it tends to, I think, push people out of their comfort zone a little bit. But it's absolutely critical not just to do it once, but to do it continuously. Because as nothing is static, right? The markets are not static. Technology is not static. Your, hypotheses about what your product is going to be useful for are not going to be static. These things are going to be changing constantly, and in order to just verify that your approach is the right approach, you need to be talking to people. And that's not just in defining the market. I mean, clearly that's very, very, very important, but it's also in figuring out who your partners are, and figuring out who your potential investors are, and that entire, and anything your company is going to be doing going forward. It's very, very important.
The other thing I always recommend is actually physically going and meeting your customers face to face. As much as we all have gotten so used to Zoom conferences, it's a really useful and productive thing to actually go put your feet on the ground and go out and see what the customers are doing. And some cases, they'll actually take you back in their labs and show you what they're doing under the hood. And this can be enormously productive. Many of our startups have gotten long-term customer relationships, even out of iCore interviews. So this is a really important and critical step in the business plan development.
Yeah, and one piece of advice I've always heard in this context is don't try to push what you're building, right? Don't sell what you think is going to be the solution. Try to learn what the problems are, right? That need to be solved, and sometimes you may get the feedback that what you're building may not really be addressing a problem that anyone's willing or able to pay for, right?
In fact, the statistics are 60% of the iCore teams discover that their original hypothesis of what the value of their idea was wrong. And they need to pivot in some way to some either new application or new construct in the creation of value.
Maybe we switch a little bit towards what the fundraising environment is in this business, in particular semiconductor. You mentioned AI is driving a lot these days. The government has a lot of interest in AI as well. Quantum is another area where there seems to be a lot of push and pull. Maybe Bruce, you want to start?
Sure. Yeah, there's all those areas that you mentioned. I think people who are starting semiconductor companies are very fortunate because there's a lot of non-dilutive funding out there, especially through government entities, but also, from universities, from state consortiums, from private entities like, Bill Gates's foundation, for example. There's a lot of non-dilutive funding available. And, to get it, you have to be doing something other than just a pure, profit-driven plan. But, there's a lot of technology out there that's what I would call dual use, where it has strategic or defense-related applications, or maybe it's, really important in the energy transition or something like that. So it's got some aspect that one of these entities that's willing to give free money out is interested in. And I think, what I've seen is that the companies I've been involved with have been able to raise multiple millions, less than 10, I'll say somewhere between, 3 and 6. I think Bob could probably comment in more detail on the numbers, but, substantial amount of money that can absolutely get you off the ground and won't be dilutive at all. So I think if you're in semiconductors, there's really no reason why you wouldn't be able to pursue that. And I would strongly encourage that. And it gives you time to figure out how to, maximize your valuation before you get a dilutive funding round.
So typically what we've seen is the NSF is the most simple place to go to get your very first funding for any kind of scientific advance. And then usually other federal agencies are willing to follow NSF. So often DOE or the DOD or other federal agencies will pile on after there's some demonstration of validation or proof of principle. But for me, what I've seen mostly is the NSF is the earliest in and the easiest to get going. And then once you have built up this, validation story, we begin the process of reaching out to the pre-seed and seed investors. That actually is the toughest part of the process, is to get off the free money treadmill and get onto the investment treadmill. It's often more painful than people expect, because you see every day announcements of 50 or $100 million investments, and it sounds like it's an easy thing to do, but I can tell you it's nowhere near as easy as they're making it sound. So that takes a lot of effort and work to get around and create your business story, but there are plenty of people around that are thrilled to help you with that effort.
I mean, another thing that I would add that's sort of particular to the semiconductor space is that What became apparent to me when we started down this path was that, a lot of software startups, a lot of startups in, other conventional spaces have a very, very short timeline to product and very short timeline to raising investment. In semiconductor, it's much longer. And I think, for that reason, maybe 5 years ago, this was not a popular space for investment, but now because of whatever changes are happening in the world at a rapid pace, it's becoming maybe more popular to invest in hardware, even though it is a longer time scale. But to the point of what Bob and Bruce have been saying, it might not make sense from the point of view of the company to take that investment early because it is a long timeline. And you don't necessarily want an investor to come in and then you're promising them something 3 years away. You want to be able to promise them something within a year. And so using that non-dilutive funding to kind of get closer to the market is a pretty good approach.
I think timing is a very critical issue, and timing and maturity. Those two things go together, and the maturity question is the issue of whether the technology is mature enough to be commercializable, and the timing is obviously where are you on your need for money, and what is it you need to do next, and how much money do you need to get to your next milestone.
Do you think the environment generally for VCs and maybe other private investors has changed due to the current situation we're in, where government funding more, that there's a lot of push for onshoring, reshoring? Because there certainly was a time where, at least from what I always heard, was that if you're in hardware, then it's just really, really, really difficult to get the kind of investment that you're ultimately going to need for what you're building, right? So has that changed a little bit? Or is it changing?
For as long as I can remember, there's been a lot of investment money out there. I mean, hardware, software. I mean, you can sort of make relative comparisons and say, oh, there's so much more money in software, which has been true.
Yeah.
But that doesn't mean there's zero in hardware. I mean, there's always been money. So that's one of the reasons our tech industry and innovation here in the US is so successful. But to your question, I do think there's been a shift. I've seen words like hard tech, deep tech. I've seen that be a lot more prevalent recently. And I think it's partly related to this increased interest in applying, Silicon Valley innovation, entrepreneurship to what were traditionally sectors that didn't really use that. For example, in the defense sector, was dominated by these huge, slow-moving, sclerotic companies, but now is really opened up to startups. So there's a lot more accessible to startups in the hardware area than I think there was previously. And you see that in terms of the emphasis that investors are making.
So we have seen that even the people that invest in software want to see some kind of long-term differentiated advantage, some kind of barriers to competition, because to the point you've already raised, although software is easy to develop and easy to monetize, it can also be easy to copy and duplicate, and there's very difficult issues with how do you defend your software, castle once you build it out in the middle of a field. So the great thing about semiconductor technologies, it's often really hard to copy them, especially if you're talking about new materials or new circuit layouts. This can be very easy to defend with intellectual property. And so the only then issue is, can we line up the funding to get through all the development cycles and get to a commercializable environment? And what I've seen is if you have a commercial potential, investors will appear. When you have no commercial potential, it doesn't matter.
So you talked about timing, Bob. When you kind of should make that switch from government money and private. I'm sure there's also possibilities to have both in parallel, right? Oftentimes that's even required, I think, right?
It's
But
certainly
there's also,
beneficial.
yeah, right. But there are
So what
also
we
more and more strings attached with government money and limitations as to what you're able to do and allowed to do with the government money. And is that where private investment can compensate for this, or?
So the federal funding, the grants we can typically get will not allow you to reimburse yourself for IP development. It
Mhm,
will not allow you to be reimbursed for market development. They will not allow you to be reimbursed for sort of capacity investments. You
mhm,
really can't make long-term capital asset acquisitions with the federal grant dollars. And you can't really launch any kind of marketing campaign and reimburse your costs with the federal grant dollars. And so where we typically see the transition hard from non-dilutive funding to dilutive funding is when you start having to put assets in the ground to manufacture your product and to begin actually traveling around and building that market presence and building your brand and establishing your identity and getting your name in front of customers. None of those things can be done with grant funding.
What about there's this expectation that fabs, more and more fabs should come to back to the country, and so startups are expected to find them as they try to build their first prototype, perhaps, right? Or when these fabs don't even exist, or very on a very limited basis. Um, how do you
Well,
navigate that?
this is something Bruce and I have been spending a lot of time on, and Alyssa's team as well. Is this transition from working at CNF or working in an academic fab to a full commercial fab environment? It's much more complicated than typically you expect, and it takes more time and more effort. And so we should expend a lot of time thinking about how we're going to do that and where we're going to do it. Recently, we've seen with the new administration a focus on bringing work back on shore, and they're no longer allowing us to outsource federal grant dollars to foreign fabs. And so
Mhm,
that's causing a lot of chaos in our development plans because there's not always easy access to onshore fabs for the exact things that we want. So bleed more time in your business plan if you're planning on developing your product with federal grants and have to go searching for local fabs.
But they're there, they're there. And especially if you're kind of in this dual use space, defense related things, you're doing products that match that market. I think those tend to be the types that would have options domestically. If you're doing some giant SoC to do artificial intelligence that relies on the latest semiconductor technology, then unfortunately most of the suppliers are foreign, although some of them are starting to build plants in the US. So even that
mhm,
be accessible depending on the exact rules. So I wouldn't say that it's a showstopper, but like Bob says, regardless of where your fab is, it's a big effort to do a technology transfer, and you definitely need to account for that in your development plan.
And is that then if you're able to do prototypes domestically, but maybe eventually as you scale, you will still have to kind of rebuild your supply chain perhaps and finding, I don't know, bigger fabs that are may at least not yet may not yet be available.
Well, and the other complication is often the biggest investors in new semiconductor capacity are foreign. So this is a very complex environment, and it
Mm,
needs a lot of attention. And it makes a big difference exactly what technology and what node you're working in
Right.
and what materials.
mhm,
And so it's hard to have a universal statement about all of this because there are just so many intricacies of every one of these questions that
mhm.
I hesitate to make any blanket statements about all
Yeah,
of
yeah,
them.
yeah. Sure, sure.
think the more reliant you are on cutting edge device technology, the more this is an issue. So if your innovation is less on the device side and is more and less on the material side, this is less of an issue. You know, we've worked with defense contractors that don't necessarily mind using an old node of TSMC technology as long as it's not fabricated in China.
Right.
So it's, you know, it's just very, very technology dependent.
Yep. And then obviously the sort of the end pricing markets models and the markets you're targeting make a big difference. If you're trying to get into a very intensely price competitive business, you might have to go offshore. Whereas if you're in a medical or a defense space, there might not be so much pressure on you to find the absolute lowest cost fab. So again, there's so many different criteria that we have to balance, and every one of our startups, we have a completely different
set of Okay. I think this kind of segues also into a topic. I know, Bruce, you've been stressing this, that companies really from a very early stage on, they need to have an eye on towards their financials and bill of materials and things of that nature, the supply chain, and you want
So yeah, you know, we're in a capitalist system, so in the end, everything is ultimately driven by the financials. I mean, it's, you know, the engineering is exciting, the science is exciting, changing the world is exciting, but you know, it's the financials that drive, and the financials drive engineering decisions. So you really have to understand your model, not just how big is the market segment, but for example, you know, is my product dominated by development cost, meaning that I'm going to sell, you know, pretty low volume, I can get a huge markup on each unit I sell, and the real big factor is how much does it cost me to develop the product in the first place. Contrast that to what's more called a cost of goods sold model, where you know, you're selling so many, it's a consumer product, say, you're selling so many that the cost of development is insignificant, but the unit cost is really important. Those drive completely different engineering decisions and engineering priorities. And, you know, I'm sort of showing black and white examples, but you really have to understand the details of your financial model so that you can prioritize and focus on the right areas. The other thing that it plays into is investors, you know, ultimately the valuation of your company, and you want a high valuation. When you switch from non-dilutive to dilutive, you want a high valuation so that you retain as much percentage of your company as possible. Your valuation depends on their assessment of what's your future revenue and income flow, and they're going to derate that by a risk factor, like what's the probability that you're really going to achieve it. So you have to be thinking in those terms and thinking about how do I convince people that I've got this high revenue flow in the future and that it's low risk. And to the extent that you can do that, you're going to get a higher valuation, you're going to retain a higher percentage of your company. And you're going to focus on the right engineering trade-offs as you go through that process.
Another thing to think about is in the end market application that you're targeting, if the customer is going to have to completely change their behavior in some way, and you're going to have to create that market, that is going to be a significant barrier to going forward. Whereas if what you have is a drop-in for the existing solution and just draws less energy or costs less or works faster, and that's going to be a lot easier to scale and develop a market for. That's not to say the first example is bad, it's just more challenging. So anytime you have to get a customer to change their behavior in some way, that's a significant barrier, but it can also be a significant advantage. Once they've changed their behavior, they tend not to want to go back.
To build on that, I think it's important to recognize that even though what we're talking about is developing hardware, a lot of times that exists within the software ecosystem. And so you know, if you pay all of the attention to developing the hardware and kind of ignore the fact that people are used to using a certain set of software to program your hardware, or, you know, a set of tools in order to use your hardware, you basically like lost half of the battle there.
Yeah, because they don't want to throw it out, right?
Well,
Unnecessarily.
they don't
Yeah.
want to necessarily learn entirely new tools.
Okay. So as a nascent startup, where do you begin in kind of trying to understand the financials and the economics of your business? Engineers, scientists always try to get the answer near perfect, right? But that shouldn't be the expectation, right? As you start.
I think this is a case where successive approximation is the best approach. Don't wait and say, oh, I can't do this for a year because I just too many variables. Take an initial stab at it, put a stake in the ground, act on that. And then as you learn and refine your model, things might shift and you might change your priorities, but it's important to start with some kind of assumption. And then to your point of what happens if I'm just not that savvy in the financials, I'm not that interested. Well, then you need to partner, so somehow get somebody who is. So, there's a lot of resources. The Cornell has a Masters of Engineering Management program, and they've provided interns, to do this kind of work for a number of the companies I'm working with. A lot of the CEOs who are former PhD students do have interest in the finances and can certainly do that if they have the interest. But there's also resources if you don't, if you want to focus on the science.
There's a great course taught in the Johnson School by Greg Ray called, forget the exact name, it's Entrepreneurship for STEM students.
Scientists and entrepreneurs, yeah, engineers, yeah.
Yeah. And so a lot of the early stage founders take that course and they get tremendous benefit out of that. Now, that presumes you have time to break away from your PhD or postdoc work. But the benefits of that course, I think it meets 2 hours a week or something. It's been a very comprehensive course. Likewise, there are courses down at Ithaca and all kinds of entrepreneurship issues. And so there's plenty of resources around to get entrepreneurship training in terms of the non-technical aspects of building a business. And Bruce and I often consult with early stage founders long before they've even founded their enterprise and gotten their first funding. And we're happy to guide people if that's open to your option.
Yeah, I think this. Go ahead, Alyssa.
I mean, I like speaking as sort of a, I don't know, a recipient of this, of all of this knowledge from these folks. It does seem like a daunting task when you start, to try to like understand what a business model is. You see a bit, these thick business plans that people produce and you've never done this before. And, how the heck am I going to build this, good financial model based on guesses? And honestly, you do evolve into it. Because you're not necessarily expected day one when you just sort of decide, okay, I might want to write a patent on this to produce a business plan immediately. That's perfect. And you can kind of pull something off the web and get an idea of like the basics of what's in a business plan. And it's extremely iterative process, extremely iterative. And every person that you talk to and everyone that you get advice from builds on that for you. And eventually you get to a point where it doesn't seem quite so daunting.
All right. Yeah. So I think this is a perfect segue into you want to start a company, right? The question is who besides you is the company? Who should be in it? Who do you want to be in it? What are the skill sets that you need to add to the team that you may not necessarily have yourself, or you may not have the interest to play the role of perhaps the business person, right? Any thoughts, comments?
So there are certain important legal issues associated with becoming a founder. And so as you're thinking about starting a venture, one of the most important issues, as you point out, Martin, is who are founders and who are just contributors. And I'm open to having discussions with people about that subject. That's one of the primary things we talk about at that early stage. And the important criteria I always explain is if they're not essential to the operation of the business, but they just are making suggestions or contributing advice, then they don't have to be founders. They can just be contributors. On the other hand, if they were critical to the formation of the IP in the first place, or they're critical to actually constructing all of the necessary elements of creating a business, then they should be a founder. The one thing you should be careful of is make sure if you're putting a founding team together that they're really committed, because losing a founder is a very significant issue. We have had a couple of situations in Praxis where teams have lost founders, they wandered away or they didn't agree. And this is a very bad sign for investors. Investors do not like to hear that founders are leaving. It's usually a destructive sign. And so be very careful. Don't add too many founders, but put all the essential people in your founding team that you need.
So what would be a contributor then? There would be advisors, informal advisors, formal advisors, and
Right.
mm,
So, for example, Bruce is not a founder in most cases. In many cases, he's an advisor.
mhm.
And there are advisory equity stakes that are offered and negotiated. And depending on the level of activity and the level of time commitment, there are many ways to establish those contributor relationships. A founder is someone that the business couldn't actually get off the ground without their contribution.
And just to add to that, we talked before about the non-dilutive funding and how you can raise, multiple millions of dollars. Obviously, your runway, how much time you have before you have to then go and raise dilutive funding depends on what your burn rate is, and that depends primarily on, your people. I'm assuming, one thing we didn't really touch on is this idea of, in-house like fabrication. If you're in semiconductors, you're obviously not going to build a multi-billion-dollar fab, but let's say you're doing some new material or small device, there's a temptation to do it yourself. But, I'm going to assume that this is all going to be based on, partnerships and fabless model. In that case, your primary expense is going to be people. So, to the extent that you can scale it down and keep it to just the essentials and enter into what Bob talked about, advisory relationships, more flexible relationships, you can really extend the runway you have to multiple years. And that gives you, a lot of time to de-risk your product, increase the probability of that future revenue stream, and therefore increase your valuation.
The other
Yeah,
thing
Lisa,
the other thing I always warn founders about is one of the people in the founding team has to have more than 50% of the equity. That's another thing that investors like to see. They don't like to see boards that are unable to come to a decision if they can't all agree. So I have been in situations where, there were 3 founders and each one had a third, and they couldn't decide anything.
yeah, I've had these stories myself too with some of the companies. Yeah, Alyssa, you have 2 of your former students as co-founders, I believe, right? And
Yeah, and I'm a co-founder as well. So I mean this was a case where I mean it's a little bit of I don't feel like I need to go into the entire
yeah.
story of the background. But it was initially started with me and one of the students, and then the second student joined later and became a co-founder. We kind of were trying to get it off the ground and write some proposals and get funding for it initially and do the I-Corps and all of that kind of stuff. And then, later on, another student joined. And I think, it is important to recognize, I think Bruce said it, I don't remember who said it, about like the burn rate, that basically, if you expand your team too quickly, then you really need to raise money really quickly. Whereas, if you have, I'm a co-founder, but I'm not taking a salary, right? So, I'm doing some work for the company, but not necessarily at the rate that the people who are taking a salary are doing it. And I think that sort of makes it possible for us to get to a point where we can raise money with low dilution rate, because we haven't had a particularly high burn rate, but it's also slowed down development, right? So those things are trade-offs.
Okay. I see there are some questions coming in here. There's this one on, oh yeah, I don't know if anyone wants to comment on this. It's not just the founders and the team. The advisors and investors can be very rude and unhelpful. Investors can intentionally cause conflict between the founders. I'm sure that happens. I'm not sure how often, but
Well, let's just say that, we talked about dilutive investing, and that one of the drawbacks is obviously you have to give a share of your company to the investor.
Right.
So your ownership is going to drop. But
mhm,
the other thing that comes with dilutive investment is, they want to have a stake. They'll often want to put somebody on the board. They might make it a contingency that you hire their favorite person to be a new CEO. There's all kinds of ways that they can exert influence and pressure on a company. So even without being rude,
mhm,
that you are giving up some level of control. So
mhm,
again, I'll just go back to the fact that, if you've made wise use of your non-dilutive stage, you've de-risked, you've got a viable product, you've got customers lined up, and you need money to scale, that's a relatively low risk proposition, and you're going to have leverage. So you'll be able to, not only command a higher valuation, but also maybe push back against some of that unwanted influence.
mhm. There is another question about, this is to you, Alyssa. Do you see more opportunities for researchers to work with established companies such as Skywater Technology, given the AI demand with NVIDIA?
There's definitely opportunity to work with established companies. That's a different piece than commercializing your technology. So if you're working with established companies, there's usually an IP agreement, and many times if that company is giving you money to do research, they're going to want some access to the IP. So they're not going to pay for you to develop something that you can turn into a company and compete with them. But I think that those particular cases, NVIDIA is a weird one, because NVIDIA kind of doesn't want to fund much external these days, is what I'm hearing. And Skywater, I think it depends on their particular partnership and their relationship with NVIDIA in this case, but certainly there are opportunities to work with industry in order to develop research projects. There's quite a few opportunities there.
I think that is a common misperception, though, that the big semiconductor companies invest in other semiconductor startups, and that's completely wrong. They absolutely do not do that. And they have major legal headaches if they would ever try to do something like that, because of conflict of interest and misappropriation of technologies and so on. So that's absolutely one of the worst places to try to go raise money, is the corporate venturing arms of the large semiconductor companies, if you are a semiconductor company developing something.
See, IP or trade secret can be lost when working with large companies. Yeah, that's where, yeah, certainly strong patents are key, right? And but it's not just the patents. Ultimately, you need to create value as a company. And point of view from the perspective of our office. And universities, I think in general, we file patents in the tech space, in the semiconductor space, but it's certainly a reality that I know all universities are dealing with, that it's very rare that universities are able to license those patents to large established companies, unless it later the technology kind of is adopted by the industry anyway, and then you happen to have, and should you be so lucky that you have a strong patent in that space, then you might be able to do a deal. Sometimes you might not be, and then you have to think about litigating, which is certainly not what anyone wants to do. Certainly not what, also not where a situation where a startup wants to find itself, right? Because if you need to litigate as a small company against a large one, you already have lost right before you start, unless you find somebody to finance it. Yeah, I think we're close to up for time. There's one question, I don't know, sort of open-ended. What is one common mistake you see repeated in semiconductor commercialization? I don't know if we want to leave that as a parting thought. Want to leave it more on a positive note, maybe, but I don't know if anyone has
I would just
a comment.
reiterate, I think, Bob said, don't underestimate the transfer, the tech transfer. I mean, I've seen so many times where you have exactly what you want in the nanofab, and then you go to move it to a foundry, or your whole supply chain, you have to move somewhere else. And it just takes so much longer, and so many kind of, seeming minor problems just magnify. You have to be a little bit pessimistic, I guess, when you go into the planning for that, and don't assume or bet that it's going to all go smoothly, and you're going to be selling qualified product like in a year.
Mm-hmm. Mm-hmm.
I would confirm that the biggest headache all semiconductor startups have is the inertia of their customers is often a barrier to them launching their commercial activity. And this is not anything new, but customers have their own interests and their own time schedules, and it often doesn't align with the needs of a startup. And so take that into account in your planning.
Yeah, and one thing I would add is that if you think that you're doing something new and revolutionary, assessing it without understanding the context of its use, like something might look great in a paper, right? Because you can like test it in a very rarefied environment and show fantastic characterization of XYZ parameter that you want. But then when you actually put it into a use case, none of those things are apparent to the user. You build a demo board and you send it out, and the user can't necessarily like understand from that demo, why what you're doing is interesting to them because it doesn't work with their system. That's like super destructive, right?
I have to go.
Oh, sorry, you said you were saying, Bob?
I have to go.
Oh, you have to go. Yeah, I know we're up for time. Thank you very much. I don't see any more questions. Thanks again to the panelists. Thanks for the audience to listen to us the last hour. We have recorded this, I think, and it will be distributed, Chris, right? To the registered audience. All right. Thanks again.
Thank you.
Bye.
Bye.